Hey folks, this is Polynomials Lesson 1, Introduction to Polynomials. So algebra is a branch of mathematics that uses symbols known as variables to represent numbers or quantities. Polynomials are algebraic expressions that are formed by combining numbers, variables, and exponents into algebraic terms. An example of an algebraic expression is 5x squared. So we're going to talk about some specific names, and you're going to have to know what these things mean. And algebraic expressions can have a different number of terms. Terms are separated by addition and subtraction signs. So a polynomial with one term is called a monomial. Okay. For example, 4x. There's just one thing there. It's nothing separated by an addition or subtraction. A polynomial with two terms is called a binomial. For example, you could have 2x plus 1. See how there's two things being separated by an addition sign. A polynomial with three terms is called a trinomial. So if you think of like a triathlon, there's three things that you do in a triathlon. So for example, let's do 3x squared minus 5x plus 6. So there's three things, and they're separated by negative or addition or subtraction signs. So a couple specific things. The degree of a polynomial is the highest exponent of a variable in an individual term. And I'll try and explain that a little farther down here. A variable is a letter used to represent an unknown quantity, like x, y, sometimes z, sometimes t, okay, sometimes a, b, or c. A coefficient is a number in front of the variable. So if we have the term 3x, the coefficient is 3. And a constant is a number that's just hanging out by itself. And the word constant means to stay there. Okay, so on the previous example, the positive 6 or the positive 1, that doesn't change. There's no letter there that's going to modify it. So those things are called constants. So let's try a couple examples here. A monomial like 4x squared. There's one term. The degree, if we go back to, the degree of a polynomial is the highest exponent. Well, in this case, there's only one exponent there. Let's get a smaller highlighter here. There's only one exponent, the exponent of 2. So the degree is 2. The coefficient is the number in front of the variable. So the coefficient is 4. And the constant, there isn't one. There's no number hanging out by itself at the end. Otherwise, it would change it from a monomial to a binomial. So here's a binomial. One thing to note, this exponent is 1. Okay? So the number of terms, there's two terms, the 5x and the 80. The degree is 1, because that's the biggest exponent we see. The coefficient is 5. That's the number outside of the x, or in front of the x. And the constant is positive 80. You don't need to write the positive sign, but let's just remember it's positive 80. All right, trinomial, there's three terms. The degree, look at the exponents. This has exponent 2, and this has exponent 1. So what's the bigger exponent? 2 is. So the overall degree is 2. The coefficients, we have two coefficients. We have negative 7 and negative 1. And our constant in this case is positive 5. So I want you to pause the video, try this chart, and then come back and see how you've done. All right, so in this case, we have two terms. That means it's a binomial. The degree is 1. The variable is x. The coefficient is 2. And the constant is negative 7. Hopefully you put that negative sign there. Okay, it's not a positive 7. It is a negative 7. So we need to tell the person reading the chart that it is negative 7. In this case, there's three terms. It's a trinomial. The degree is 2. The variables are n. The coefficients are 3 and negative 4. And the constant is positive 7. You don't need to write the positive sign. You only need to tell me whether it's negative. All right, we got two terms. That means this is a binomial. The degree is 1. The variable is r. The coefficient is -9, and the constant is +2. Again, you don't need to tell me that it's positive. It's implied that it's positive. Now the last one here, there's one term. That means it's a monomial. The degree is 0. There's no variable, okay? So there's no variable. The degree's got to be 0. There's no variable. There is no coefficient. It is only a constant. It's just 54. It's just hanging out there by itself. In this case, just make a note. There is no variable. So the degree is 0. Because if you remember, anything with a degree of 0 just turns to 1. Okay? Okay, let's try some representing with algebra tile. Now, we're going to use this legend, meaning that the positive values are black and the negative values are white. In some other cases, some other texts on other, like a PAT, exam, other courses, it is not limited to black, white. Okay, sometimes they'll be red and blue, sometimes they'll be white and red and black, red and green. Okay, that's why you need to consult the legend or the key to figure out what are we actually working with. And in this case, we are working with black and white. Okay, black tiles are positive and white tiles are negative. Now, back to the last unit we just did. If I said like 12 squared, what would you do? Well, you draw a square with side lengths of 12. Okay? Well, x squared is the same thing. It's a square with a side length of x. So if you see an x squared, you draw a square. So let's represent this. Okay? So x squared, well, we have 1x squared. And is it positive or negative? If it's positive, you got to shade this bad boy in. Okay? And then we're adding 5. Now, single numbers are represented with little squares. So 1, 2, 3, 4, 5. Notice they're different sizes. This is the x squared, and this is the positive 5. Next example, we have 2x squared, and they're both positive. So let's do 2x squared, big ones, and negative 3x. Notice this negative sign here. So we're going to be using these negative x ones. And we've got 3 of them. So you draw 3 rectangles, the same height as your x squared, but not the same width. And we're done. This is your 2x squared, and this is your negative 3x. Negative 2x squared, so we are drawing 2 squares, big ones. We're not shading them in because they're negative. All right, this is a negative x squared, and this is a negative x squared. We have positive 4x, so we're going to do 4 rectangles, and we are going to shade these in. And then we have negative 6. So we have 6 little squares that are not shaded in. So which polynomial does each group of algebra tiles represent? So let's think about this. This is a positive x squared. This is a positive x squared. We've got negative x, negative x, negative x, negative x, and negative x, and plus 1, plus 1, plus 1. So let's combine it all together. We've got 2x squareds. We've got negative 5x. And we've got positive 3, all grouped together. In this case, The orientation of some of the things are different, but they're still the same thing. Negative x, negative x, negative x. We have another negative x, we have another negative x. So in total, we've got negative 5 of them, and we've got plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. So negative 5x plus 6. In this case, we've got different orientation, meaning some of the rectangles are vertical and some are horizontal. And we've got stuff not grouped together. We've got this one here and this one here. So let's start with the biggest tiles. So we've got negative x squared here and negative x squared here. So in total, we've got negative 2x squareds. We have positive 6x. Those are the big rectangles. And we have negative 4. All right. Here's another polynomial. Now we're still doing the same thing, that white are negative and the black tiles equal positive. Okay. So how many different shapes do we have here? We have big squares, we have rectangles, and we have little squares. So that means there's 3 different things. So the number of terms is 3. It's a trinomial. And what are the coefficients, constants, and degree? Well, let's figure out this actual polynomial. So we've got negative 1x squared, negative 2x squared, negative 3x squared, negative 4, and negative 5x squared. And we've got positive 3x, that's those rectangles, and we have positive 4. So let's use this information. The coefficients are going to be negative 5 and positive 3. The constant is positive 4, and the degree is the biggest exponent. So that's going to be 2. The polynomial expression 2x squared minus 3x minus 4 can be written as any one of the following. All right, so let's just take a peek here. So we've got positive 2x squared. So scanning through the list, this is still positive 2x squared, still positive 2x squared. It's still positive 2x squared in that one. Still positive 2x squared. And finally, still positive 2x squared. Then negative 3x is negative 3x in any one of the cases. And the negative 4 is negative 4 in all the different variations. Notice how the signs stay with the coefficient they belong to. You are quite literally rearranging algebra tiles. So whether I place the 2x squared on the right side or I put them on the left side, they're still the same thing. So you are just rearranging the tiles. You're not changing the color of them. So pause the video. I want you to match these tiles. Okay, so basically here's your expression, and you need to scan through the options and figure out which one is it equivalent to, and put the letter. So it's going to be A, B, C, or D here. One of those, okay? Okay, so hopefully you figured this out, that if we rewrite A in descending powers of x, we get x squared minus 3x plus 2. And if we scan along the options, that's going to be equivalent to this one. Okay. The next one, if we rewrite in descending powers, we get x squared minus x plus 3. And if we scan through the list, that's the same as this one. If you rewrite this one, 3x squared plus 4x minus 6, that's equivalent to the first one. And the last one, again, if you rearrange 3x squared minus 7x plus 6, that is the second one. So CDAB is what you should have written down. Hopefully you came to that same conclusion. And that's the end of this lesson. There's going to be homework that follows as well as an assignment.